All right. Hello, everyone. Can you hear me just fine? Yes?
Yeah, I can.
Okay, cool beans. All right, let's get started. I'm assuming everybody looked through this document where it's just the pre-lab instructions and how to set up your MU application. Yeah, no? It's just basically, where did I put my, here we go. Okay, it's just basically the first part of the lab. Before you start exercise 1, they want you to upload your MU application. And I uploaded a document where it's far simpler to follow through. You just go to this code with MU application, website, and you just download it via these links instead of not within the alpha box, which would be shown right here. So don't click any of the links shown here. You want to click one of these links because they're older versions and they support the Adafruit packages. So all that information is there. Yeah. Yeah, and there's a setup where, like, if you don't have, for instance, if you are not able to connect to your Feather board, then that means you're missing out some of the CircuitPy drivers, and there's also instructions how to troubleshoot that as well. It would be found in this particular, I think. Yeah, so you can download the latest CircuitPython, or that's for a different issue, which is when you don't see CircuitPy as your F driver. But here, install latest Windows drivers. I don't know about the Mac, so whoever's got Mac is on their own on that one. Okay, we'll just, any questions before I start the exercise? Yeah. What's up?
With screen share here, it makes it difficult, but not necessarily impossible to access SMU and the lab instructions.
Access SMU and the lab instructions? Oh wait, so you're saying?
Because when it's on screen share, it covers the entire screen.
Oh, I don't understand. Wait, are you saying? Well, wait, what are you saying? Are you saying when I'm screen sharing right now, you're not able to see the Google Doc or that I'm showing right now?
No, it just makes it difficult.
Oh, so you can't see, I don't understand. You can't see what I'm showing, or?
Well, I can see what you're showing. I just, I know that, but.
Oh, we can pin the video.
Let's continue.
Okay, okay. All right, so exercise 1. Anybody have any more questions? No? Yes. All right, so let's assume that you have your MU application downloaded, and so I'm gonna just start the MU application running. Let's see. So I'm gonna plug in my, can you see? Okay, so you can see this is the Feather board that I've got right here. It's connected to the micro USB. I'm gonna plug into my computer. Can you see the MU application and other files open? Yeah. All right. Are you guys able to see the MU screen?
Yes.
Okay, thank you. All right, thanks. All right, so I'll just click serial. That means it's, you know, it starts the connection between your Featherboard and your application. You can see the green light, the green indicator, meaning it's all good and running. If it shows blinking, flashing red, that means there's an issue. And there's other color-coded meanings behind the Featherboard, as you can see here. It lists out when you're typing up your code as well. So the first thing we're gonna do is, so I mean, if I press enter here, you can see that it gives you the CircuitPython version for anybody else who's confused. This is the RIPL area. So it acts like a, you know, if you're familiar with MATLAB or whatnot, you can type in text here as well. But we prefer to just write our code in this screen right here, in this window. So the first exercise is we're gonna just copy and paste this just to see how it works, just get an idea of. And then when you save it, you can, when you save it, you're supposed to save it as code.py. It won't accept any other file to run. So whatever you have other files that you need to use, you should copy and paste it into this code.py, and then whatever comments and stuff that you want to preserve, you have to actually open up a new tab and save it under a new file and save it onto your PC. So I mean, I'll go through that process just to give you an idea. Yes, okay. So when I click save, it automatically runs it. Okay, so you see the little red light that's blinking, the LED that's blinking? So it's basically turning on and turning off. So as you can see here, when we use the code import board, import digitalio, and import time, those are all classes within Python. So, and then when we state digitalio right here, so we're equating it to a variable LED. So the first thing is whenever you're dealing with CircuitPy and a board, you always want to, especially when you're dealing with I/O input and output pins, you always want to state the input output pin that you want to communicate with on the board, and then you want to state your direction. And this situation is the LED, so it's giving an output signal. So the flashing indicator light is a signal. And so you have your while true loop. You say LED value. This means that basically you're equating the LED variable to a value to true, which means high, which is in this case 3.3 volts. And then you want it to blink at half a second by turning it on and then turning it off with the terms true and false. Any questions? No? Okay, so whenever you want to stop running your code, you can always type in Control-C. So I just interrupted it, and then it gives me the command Control-D to reload whenever I wish. Okay, and then you can see that the light switches, the RGB light indicator light switches between blue and green. Okay, next. So we already have that. As you can see, like when I connected the USB, it called this a CircuitPy F drive. So if you see this, that means you're good. You don't have to deal with the whole downloading UF2 file. But if you don't, then just read the instructions where I mentioned how to download the UF2 file. So this is talking about the RIPL command window. What else? So the NeoPixel colors and blink patterns. Okay. I mean, so this is an extra exercise. It's just to see like how the ripple would respond. But I think I'll just skip this for now because we're running on a time frame here. But we can. I mean, who's comfortable in skipping this part? This is just experimenting with the ripple command command prompt. Should we move on to exercise 2? Yes?
Yes.
No? Yes, okay. Thank you. All right, so let's go to exercise 2. Using the blinking program. So replace the loop portion with the following. So we're gonna replace the loop portion with this guy. So I'm just gonna copy and also if you ever wanna comment out, you can comment out with a hashtag. I know like whoever MATLAB users, we use %. So you can always comment out with a hashtag.
Question, TK.
What's up?
Can we comment out a block, you know, not line by line?
I think so. That's a good question. Let me see. I don't think so. Yeah, I don't think so. You have to do line by line, unfortunately. Okay. All right, so I'm done pasting this guy, so I just click save, and it loaded it up. And so as you can see here, turns on, I think, wait, did I copy? Oh. Oops. My bad. I was like, why? It should be blinking. All right. Okay. Okay, maybe let me put Control C. And then Control T. Let's look at it now. So yeah, just turning, it should blink, but I'm not sure why it's not blinking. Ah, that's why. Sorry guys, missed a few lines of code. Okay, now it's blinking. All right. So as you can see here, we're using that count command, which is basically you're counting incrementally by 1. That's what plus equals 1 means, and then you can print out the count. And it's blinking at 0.5 seconds, and it's true and false, meaning high, low, in between the sleeping, in between the intervals of its blinking. All right. Any questions? No? Okay. All right, so let's move on to exercise. Okay. Wait, we're still on exercise 2. Okay, so this other thing is like using this test run where we will just type in some random term. In this case, it's going to be barf, right? So let's stop our code. I'm going to stop it with Control C. And then I reload it. Well, maybe I should save it. And then, as you can see here, the indicator light is it's saying error name barf is not defined, and it's giving me this white, blue blink indicator flashing light, and it's with the green. So that means there's an issue. Remember, when it's constant green, it means that your program is good. If it's not, then there's an issue. So to rectify this, they say, okay, so let's move it to out of the while true loop, right? So by getting it out of the while true loop, you just, let me just put Control C to shut it off, to cut up, and then I just backspace it, and then I save it again. So when you hit save, it should automatically upload. But if it's not, you can always just Control C. You can just always press Control D. And here it is. It's blinking back again, right? The indicator light is green, constant green, and it's counting again. So and so the question is like, you know, this is what you're supposed to answer in your lab report. It's like, why this is the case. Why did it work when you put the barf term outside of the while true loop? Why did that work versus when it was in the while true loop? If you want to answer it now, you can answer it, but yeah. If you guys are comfortable, no questions. If there's no questions, we can move on to exercise 3. Yeah? Okay. All right, we're moving on to exercise 3. All right, so let me cut off this program, Control C again. And so we're gonna be using the tripler board. And the tripler board is this guy right here. It's called a tripler board because it will have 3 boards stacked to communicating with one another. So you got this board where they call it the wing, and this is the base, the triple board base. And then when we connect the feather board to the base board, to the triple board, we will actually be using its pins and its switches or buttons. We'll also have a servo connector, and this wing board has a potentiometer as well. So, okay. So we're gonna connect the feather board to the triple board, and to do that, the first thing you would wanna do is always make sure that you disconnect your board. And to do that, you would want to right-click it and select eject. So you just treat it like a flash drive. Make sure you align the pins. You got a shorter length and a longer length right here. That's weird. I'm not gonna use for it. All right, sorry about that. For some reason, the other feather board had its pins misaligned, so. Okay. Holy crap. Okay, so all right, so we got it's connected. So we got the triple board, and then okay, so let's see. We need to upload a code. Appendix B. Okay, so let's go to Appendix B because it's asking us to go to Appendix B. Let's see. Appendix B, it shows you a table. So you got TB meaning triple board, and it shows you the designated pins associated with the particular indicator lights. So if you want to see green, you should use pin 9. If you want to see red or use LED 1, you should use pin 6. And here we are, we have LED 1 right here and LED 0 right there. This is the RGB light in the middle. Yeah. Okay, all right. Oh, any questions? No? Yes. Okay, all right, keep going. Okay, so basically we're gonna modify the blink code to using D5 and D6. So I think I already did that sometime before. So if you wanna ever upload a code, you can do so. You just have to save it to your PC and hit the upload option. I think I put it. Yeah, okay, I put it in here. All right, so you're gonna modify the code to have pins 5 and pin 6. Just to save time, I'm just gonna upload what I worked on. So I'll just copy and paste this guy. Copy, paste. Okay. So here you're still using the same classes, but you're connecting to different pins 5 and 6 because of the fact that you are connecting the feather board to the triple board. So I'll be using different pins, and then you'll be using LED 0 and LED 1. So you'll be defining the pin and the direction for each LED. And you'll be stating, you know, true, false, high, low, basically. Yeah. Okay, so I'll just save this guy. And I'll just press Control D to run it. And so as you can see here, you see LED 1 and LED 0 blinking, taking turns blinking. Oh, can you guys see it? Or is it difficult to see? Can you guys see the blinking LEDs?
I could see it.
Okay, cool. All right. Yeah, just holler, you know, just let me know if you guys can't see something, or let me hit the contrast. Let me hit the contrast one. Okay. Okay. Let's see. And then the next thing we need to do is yeah, and then you have to call this ucode blink 2. And then you can move the jumper to the RGB position and also report the outcome. This basically, you know, you're just basically going to light up the RGB. And I think to do that, you just have to change the pins as is indicated in Appendix B. So Appendix B kind of, as we've seen, shows you the pin numeration with respect to which LED you would like to turn on or off.
Sorry to interrupt, but do we upload like the little code files that we do along like with the lab report, or do you just want pictures of it in the lab report?
Yeah, sure. Yeah, I mean, whatever's easy for you. You can upload images is fine. uploading images or copy pasting the code. I think uploading images is probably, it's probably much better maybe. If it's viewable, because sometimes, you know, it can get way too bulky and get too big and you can't see the code. So as long as the code is visible.
Okay, thank you.
No worries. Okay, well, let's see. All right, so, and then you just kind of continue. I mean, you can just further read if you want. All right, so should we move on to exercise 4? Yes, no?
Yes.
Okay, thanks. All right, so let me just stop this guy. It's not stopping. Okay, never mind. All right, so let's go to exercise 4, and this one will be going to. Okay, so we'll be playing around with the switches and the LEDs on the trigger. I mean, triple board. Okay, let me load this guy. Think. Let's copy this part. I think I should show you how the original code should look like as well. So I think it's not fair if I just show you what's been already done. Okay, let me just show you how the original code would look like. It would look like press to light. So it would give you all this, your pins and, you know, the pin direction and whatnot, and the switches as well. So as you can see here, we use the term pull up for the switch input direction. It doesn't necessarily mean that the switch is unpressed. You know, it actually means something else. So if you, I think it was it appendix? I forgot what appendix was it. Was it appendix D? I think it was appendix D. Here we go. Okay, so as you can see here, we have the schematics of the triple board. And in this direction, we have the buttons. As you can see, it's labeled here as buttons. Is it clear? Can you guys see my screen? Okay. Yes? No? Okay, so this is the ground and this is switch right here. And basically pull up describes the location of the, a chat room. Let's see, we can see it. Okay, thanks. So it just basically explains, more chat, we see. Okay, thanks. So this is the resistor, and it's basically talking about the location of the resistor with respect to the switch and ground. So if you have designated as pull up, that means it's corresponding to how the resistor is positioned with respect to the ground and switch. If the resistor is positioned between the ground and the switch in this location, it will be actually called pull down. And that has something to do with the fact that when you open up the circuit like this with the switch, you will create a variable voltage, and this resistor prevents that variable voltage from running free, from escaping into the rest of the circuit. So yeah. Any questions? Yes. Oh. Okay. All right. So let me just run this code. And then this is just not switch 0 value and not switch 1 value. So it's just basically turning it on. Let me save it. And then Control D. Why it's not responding. It should. Okay, I need to stop that one. wonder why. Okay, let me just eject it. For some reason, it's not responding. Let me just eject it. Okay, so let me save this guy. I don't know why it's not working. Oh. Okay, sorry about that. I was in the wrong tab. So I loaded it, and as you can see here, it's not blinking anymore. So, but when I press the switch, it blinks. So, right, 0, switch 1, it blinks. So I mean, that's what it does. You're just connecting the switches to the LEDs, and you can equate that by using this, equating the values between the LED and the switch after you designated the pins and the pin directions. Let's see if there are any questions. Okay, so then explains why the circuit behaves as it does with respect to getting true or false. So, yeah. Well, true means high and false means low. So it's 0 volts, 3.3 volts, and yeah. Okay, all right, so you guys have any more questions on exercise 4? Should we move on to exercise 5? Okay.
Yes.
All right. Okay, thanks. All right, let's move on to exercise 5. All right, exercise 5. All right, the report analog thing. Okay, let's load. Okay, let's load. Let me. Okay, so. Okay. So this one we're going to be working with a potentiometer, hence the term pot. Let me load where the actual code will look like. Hold on. And report analog. So it looks the same. It's just that, you know, I kind of filled it up with some comments. Yeah. Me too. Okay. Oh yeah, yeah. So I added some other extra things to it. Let me just comment that stuff out at the moment, because that's for the temperature part. So we want to just, that's for the temperature part. So just print pot value. I'm just going to be printing the pot value. Okay. And then I'll just comment these suckers out. All right. So digital input handled versus an analog input. So, okay, so we're gonna run it first. Save it. Let me see if it's right. And this is the potentiometer right here, this dial. So it should be printing, but it's not printing. So let me just press Control D to reload. I press enter. Okay. Oof, it's giving me issues. I don't know why it's giving me issues. Okay. Hopefully I don't have to restart it. Okay, for some reason it's not. Should be loading. Okay, let me just restart it. Sorry, guys. County maintains. Okay, now it's working. Oh, jeez. Okay, so as I'm rolling the potentiometer, it's printing the pot value, and yeah. As you can see here, I wrote the comments that digital expects high or low, and analog means variable, and these are all bits that's giving in the values between high and low. So if you roll the dial on one end, you can see that the maximum value is 65520. You can write that down if you want. And then when I go really low, it goes down to like 128. That's the lowest. So you have like an idea of your maximum and minimum bit values. And there's a conversion. So a lot of these values that you see in the count or printing pot, or the values, printing the values of whatever device that you're getting signal from, readings from, they will give you, there is a conversion to it. So they're basically converting voltages to bit values. So yeah, and this is board.A2, so meaning that the pot is connected to A2, pin A2, and A stands for analog. And notice that we are using the class Analogio instead of Digitalio. So yeah. Okay, any questions? No? All right. So I'm just gonna cut this guy off.
Hey, TK.
What's up?
What is the one next to the BOT?
This one right here? Or this one?
In the board.
Oh, in the board? Oh, this guy?
Yes, that's one.
I'm not too sure. I haven't played it. I haven't played with it for this lab. So this lab we're not going to be messing with this guy. I forgot what it was. I think it's a dial of some sort. I'm not too sure what it is.
Thanks.
Yeah, sorry about that. Yeah, I don't know yet. Okay, so now we're gonna switch into adding in the temperature. And if you wanted to know where and how to add in so whenever you want to add in a certain device input, you need to know what pin it's connected to, and you just go to Appendix C. You scroll down to Appendix C. You can see that temperature is A1 right here, and yeah, this W stands for the wing, so I don't know what I means. Maybe interface wing board perhaps. So it's this guy. Yeah, and pot is A2, and that's why A2 was used in the code for a potentiometer. Right. Any questions? I'll just continue trying to finish exercise 4. All right, so I'll just uncomment out these guys. This is for the temperature stuff. And make sure that you are indenting properly, because Python is really sensitive about indentation. So yeah. All right, so let's save this guy. And right now it's, oh shoot, I forgot to start off the plotter. Okay, so this is the plotter right here. As you can see, it started at 0 degrees first, and then it went up to, 0, and then between 1600 and 3200. And this is its bit conversion. So you obviously 0 is associated with 0 degrees, and then whatever in the middle here is associated with room temperature. Yeah. So if I deal with the potentiometer, you can see that the blue is for the potentiometer. So I'm moving the dial up and down, and that's why you see it oscillating in this fashion in a stepwise way. And then for the temperature, if you're actually really curious and you want to make it jump up, you can always grab your cell phone and turn on the flashlight and put it really close up to it. And then you can see it just oscillating just a little bit, not too much. Okay. Any questions? Oh, by the way, you guys can actually take screenshots. Do you guys want to take some screenshots?
This is going to be recorded, right? And then posted on Canvas.
Ah, yeah, it is. Okay.
So, will we be able to see both the video of what you're doing right now and of the code from the recordings?
Yeah. I mean, you should be able to see everything. It's like yeah, as long as I'm still sharing, you can see whatever's on the screen.
Okay, thank you.
Yeah, no worries. Okay. All right. Okay. All right. So should we move on to next exercise? Do we have any questions? No? Yes. And then record the minimum and maximum values read from the temp sensor. Oh, yeah. So as you can see, it's, yeah, you can, just remember the green line is for the temperature sensor. So, and it started off from 0. So, okay, let's go to, okay, what's this? We're using new to graph data. Oh yeah, I already did this one, but oh, this is optional. Okay, so we used the plotter. So that's what it was doing. You just select this plotter. So, okay, we just finished part 6. All right, moving on. Let's go. Okay, so part 7. I've already downloaded the Adafruit motor library. Yeah. From this link, yeah. So you just go to this link and you download the Adafruit. Let me just show you. Let's see. Yeah, so it's just this guy. It's just the same as, yeah. You just download this guy and then yeah, you should install it because it has the Adafruit motor library, and you want to use that in your code. So let's go to servo twerk.pod. Let's. Okay. Let me load. What did I do? Comments. Okay. Let me load. How did the original code look like? Okay, so this is how the original code looks like. So, okay, so the original code had, oh yeah, and also to shut off the plotter, you can just select plotter. Yeah, and then this guy, I think I cut it off already, right? Yeah, I did. Okay. So, I mean, you're importing the, this is where it is from Adafruit motor library. You import servo because we're going to be using a servo. And you're importing time, pulsio, and board, and you define that the servo is going to be connected to pin D4, and I believe you can see that in the appendix as well. They will show you what pin that's associated with. And the maximum it can turn is from 0 to 180 degrees, so be mindful of that. Yeah, so yeah, and this is 2 to the 15. Remember, double multiplication means to the power of in Python. So it's just the duty cycle defined in terms of bits. So this is the highest voltage, 2 to the 15th. I advise you not to go higher than that. So yeah, it has a certain offset as well. So okay, whatever. Let's run this guy. Okay, let me just copy. Okay, first off, let me just I need to disconnect first because I want to connect the servo. So this is the connection. This is the connector where we're going to connect the servo. Make sure it's labeled. So you have control, 5 volts, and ground. So black is ground. So make sure you're in that particular orientation. And then you insert it in there. Okay. And let's go back to our new application. Okay, so let me just save this guy and oh shoot. Okay. Oops. I didn't realize Sorry guys, I accidentally deleted the code.py. Hold up. Okay, let me just save this guy. You want to save it as, oh, my bad. Oh, that's how you have to upload it. Okay. Why do I went all the way back there? Okay, let me just save it as, no circuit. Let's save it as code.py, enter, yes. So you oftentimes, as you can see, oh, there we go. So it's turning between 0, 180, and 90. Oh. Guys can see it, right? Okay. As you can see here, it's switching between 0, 180, and 90. 0, 180, 0, 90, then 180. 0, 90, then 180. So if you're confused about which orientation is going, just follow the direction of one blade, and that'll be able to, so let's go back to 0, 90, 180. Okay? Any questions? No? Okay. Let's see. Where do we have it? Yeah, grab the function of the RC solver as controlled by this program. Okay, I think that's about it for that one. Yeah, I mean, I think we got curious, and we decided to run with. Let's see. Yeah, so we decided to run with like 45. You can actually do that. You can add, if you get curious, you want to add in another angle, you can type this up. So, yeah. Okay, moving on to the next exercise. Okay, so part 8, we're going to be playing some music. So let's see. Okay, let me just interrupt this guy. Press Control C again. Oh, doesn't want to listen to me. Okay. Doesn't want to stop. I don't know what's going on. For some reason it doesn't want to stop. Oh, jeez. Okay. Let me just disconnect it then. Eject. All right. Sorry, guys. For some reason, Control C is not working well for me today. Okay. So I'm going to be disconnecting the servo. And then reconnecting my board. All right, so we're gonna be playing the tone melody. Let's see. Let's see. Okay. This is how the original code looks like. So as you can see, they're using different notes. They're using pin A3. Yeah. So, I mean, you can read it through and kind of, it's pretty self-explanatory if you just take the time to kind of understand what's being stated. So that right here, when they say def play, or whenever they use the term def, and it's basically they're defining a function. So any MATLAB users, we used to like create a function in a separate file, and here you don't. You actually use this command line def, and then this is the name of the function, and then here are what they call as the attributes, right? So you have the speaker, PWM, which is pulse width modulation, and that's where the duty cycle is defined. And then you have the frequency. This is the amount of occurrence per second, and and the duration. None means all. So basically, it's taking in all the music notes. So yeah. So we can, I think we just have to play it, right? That's all we have to do for, yeah, I believe so. Oh, never mind, oops, no further. Yeah, just gotta play it. All right, let me just copy and paste this guy then. Yeah, so often you have to always like copy and paste your code into the code.py a folder, because it will only read and load the file from code.py. And then if you make any modifications, as you can see here, like I would define it with I would preserve the name of the code, and I say with comments. So I would add my own comments in there, or make changes and then save it to my hard drive on my PC or outside of it. We got no more room. All right, so let's save this guy. Let's run it. Oh, okay. Let me run it again. Can you guys hear it? Is it too low?
No, I can't really hear it that well.
No.
Oh, shoot. Okay,
It's
hold
pretty quiet.
on. Okay, let me push it. I have to move it closer to my own computer speakers. Okay, let me play it again. Can you hear it now?
I could hear it that time, yeah.
Yeah, that sounded much clearer.
Okay. All right. So okay, let me just play it again so you guys can commit it to memory. So, and then all you have to do is like for this exercise, you just write down what type of melody it's playing. Yeah. Okay. Awesome. All right. Any questions? Any questions? Yes. Okay. All right. Moving on to part 9. All right. So breadboard example. Yay. All right. So we're going to be connecting the feather board to the LED and the resistor. Yeah. And then we'll run the code for it. So we'll be using the blink.py. Yeah, we'll be using the original blink.py, I believe. Yeah, because we'll be using pin 13. So yeah, okay. So let's see. Let me load blink. Okay. Oh wait, let me just put Control-C. Trip. It doesn't work for some reason. Let's copy, paste it onto this guy. You guys do know where you guys can find the files for the code, right? So I uploaded the codes to in the file section, and there's a particular folder for it called Intro FM4 Codes. All right, so let me eject this guy. so that we can put our boards, our circuit together. Let me eject it. All right, so we're gonna, so we're given like, you know, the little box here, and in the box we had, wait, did it say I can remove it? So let me just remove the feather board. So as you can see here, I already put the LED and the resistor together, and this is just the wire. So this one, so keep note that that the LED has a shorter leg, which is called the cathode, and it's connected. So over here, so you can see that there's a shorter leg. So a little shorter leg is the cathode. That's connected to the ground. The longer leg is the anode that's connected to, which is positive, which is connected to the resistor. So remember that, you know, we connect vertically. So let me put this back. Okay. And then I can just connect my featherboard. Like so. Okay. And the ground will be connected, so you don't have to like connect to like other grounds and stuff. Oh, can you guys see? I guess you guys can see. Okay, so this is the ground wire. So I'm gonna be connected to the ground pin. Okay. And then this is the connected to the pin for reading the LED. So between the resistor, so everything's connected. Okay, so do you guys have any questions about this circuit? No? Yes. Okay, never mind. All right, so I'm gonna connect it. Okay, now let's save it and run it. All right, there you go. So as you can see here, it's, you know, the red LEDs are blinking in tandem. So, and it's just, you know, yeah, just blinking. Oh, can you guys see properly? Can you guys see that the LED is?
Yes.
Yeah, we can see it.
All right, cool. All right, so I believe we're done with this exercise. Include a digital photo of the final circuit, connect to your setup with both LEDs on. I have a photo. I mean, I've already taken a photo, so I think I can just upload that. Or you guys can just take a snapshot of this later on. All right. Okay, so I guess we can move on to exercise 10. Everybody comfortable moving on to exercise 10? Yes?
Yeah, that's
Okay, awesome. What was exercise 10 again? Okay. Let me just cut this off, Control C. This dude ain't working. I don't know why this did. Control C is not working for me. That's so weird. Okay. Okay, let me just eject it. Okay, let me eject this guy. Save to remove hardware. Okay. So I don't think I need the circuit anymore, do I? I don't remember what I was doing. Oh, this one. Okay. I think we're still using the circuit board. Oh, we were here to, okay, we were to visualize it using the scope. What? Okay, let me see. Oh, my bad. I'm confused. Ooh, I don't remember this one. Okay, let me just upload it. And upload it. Okay, let me just. BPW. Oh, that's weird. Okay, I guess it won't respond until I connect it. This is weird. Okay. Okay. I think we're still connected to this guy. Okay, I think we're, yeah, I think we still used the circuit board. Okay, so yeah, so okay, so the pulse width modulation will be used to turn on and off LED. You can vary speed and the voltage. Okay, yeah. Okay. Sorry guys, I'm trying to remember what I did for this one. Okay, let me just copy and paste it to code. Let me just load the original code. Yeah, okay, just the same thing. Oh, yes. Between my connection, serial. Okay, let's see. Oh, it's giving me an error. Okay, let me just, I think I just have to, for some reason, I don't remember if we still used. Anyways, let me just go. Yeah, it's not responding. Okay, let me just run it again. Okay. So, hold on. Okay. As you can see here, the LED is kind of like fading in and fading out. So instead of like using a potentiometer like the last time where we had to control the fluctuation of the voltage, this one has its own internal pulse width modulation going on. So you can see that the LED is fading in and fading out. And for this exercise, we're supposed to be using a scope to basically visualize the duty cycle. So let me just get that jumper wire and the scope probe. Actually, you don't need the jumper wire. You can just. Okay, so let me get the camera so you guys can see. As you can see, you know, alligator to ground, and then the other probe hooked to the positive end at the ends of both LEDs. So let me just detach this camera. Sorry, I forgot to show you guys last time that this camera can actually detach itself. I didn't realize this until a friend showed me. So here you go. I'm gonna show you how this scope looks like. Scope reading looks like. As you can see here, you can see the pulse width modulation plots. Can you see it? No. Uh-oh. Let me know if you guys can see it or not. Okay.
Yes.
Okay. Thank you. All right. So that's how it'll look like. But just make sure that the ends don't touch. So you can see here that it's undulating between high and low. So yes. Okay. Awesome. All right, moving on to part 11, exercise 11. All right, so in this exercise, you're going to be creating your own code using the servo and the potentiometer, I believe. You're going to be putting them together to create your own code by having, so I'll give you guys an idea of how it would look like. Let's load, where did I put it? Oh, do you guys have any questions? It was pretty straightforward.
Yeah, it made sense.
Okay, good. Let's see. I think this one. Okay. Yeah. So as you can see here, you still have to import the Adafruit motor. And import the servo class from this library. And these are other. You have to import analogio and pulsio, and make sure you designate the appropriate pins. And then the potentiometer, and the servo with respect to its duty cycle and frequency, and then the activation range for the servo. And then you dictate the servo angle. So what you're gonna do is basically dictate the, equate the angle of the servo with respect to your potentiometer. And this is a conversion for it. So pot value minus 190, this is the offset. 190 is the offset, and 2 to the 16th is like a really high voltage, like the maximum voltage. You can put 2 to the 15th if you want, or 2 to the 16th, it doesn't matter. And then you just print out those values. So you print out in one column the pot value, and then you print out the angle of the servo, and in between each reading you have a 0.1. It's a reading of 0.1 seconds. So I mean, I can run this just to give you guys an idea how it looks like. So let me, for this guy, let me just cut off this reading. Okay, and then let me, I have to eject it just to be on the safe side. So what I'm ejecting is basically the micro USB connected to my PC, just to give you an idea, because it's not shown on the camera. I'm going to be disengaging the feather board from the breadboard. And then I'm going to bring in the triple board. Load this guy up again. Okay, there we go. And then I'm going to connect the servo again. Okay. And then I'm going to load the feather board back to my PC. So what I'm going to do is I'm going to, oh, did I already copy and paste it? No, I didn't. Okay. All right. Maintain that serial connection. Okay, I'm gonna save it. All right. So yeah, one side you've got the what was it? The servo angle, and then the other side you've got the pot value. So as you can see here, I'm rotating the potentiometer, and then the servo angle is also rotating with it as well. So do you guys want me to run that again, or was that good?
Could you run it one more time, please?
Sure. Okay, let me run it again. Okay. Was that good, or do you want me to run it again?
That was good. Thank you.
Okay. All right, so I believe that's about it.